In this lesson, I'll be talking about an intro to creating sheet metal enclosures. So we're going to be creating a fairly simple enclosure around this PCB board. And while I'm working on this, keep in mind that this enclosure isn't necessarily meant to be a production model, but more to show techniques on how to go about creating the parts that you'll be working with, or the enclosures that you'll be working with. For example, the actual assembly size here is 3 inches by 2 inches by about 1 inch. So in reality, we probably wouldn't be creating an enclosure around this PCB board. But in this video, I'll show some techniques on how to get started on creating enclosures, and in subsequent videos, I'll get into more detail on creating specific enclosures. There are a few ways you can go about creating enclosures. You can create all of your sheet metal parts separately. And typically these are all going to be built in context of some other parts. For example, in that first enclosure, if I go ahead and hide out the top sheet metal body, this started as an assembly, and the enclosure was built in context to this PCB board, as well as a few PEMs that we have available. And so when working in this manner, we're going to want things to be able to update on their own in context, especially if we change the geometry of this PCB board, for example, or if we have multiple configurations, we want this enclosure to be able to update on its own. And I won't go into any detail on working with configurations or equations on this video, but I will in later enclosure videos. So there are several ways that you can build enclosures. We could build this all in one part, similar to a master model method, like one that would be used with a surfacing model. I don't recommend that, as it's very hard to add in components after the fact, and it makes it a little bit messy to work with the individual components. And essentially what I meant by that is that in the part environment, I build everything. For sheet metal, I would not recommend this. And the two other ways you can go are creating your enclosure as a single part in multiple bodies. And this makes sense for very simple enclosures, such as this one. And generally makes it easy to update the components as you work with them. For something a little bit more complex, it generally depends on what you're going for. You could build several of these bodies in the same part. Typically, as I did here, I would build all of these sheet metal parts in individual parts. Except for possibly in a case like the back plate, which is made up of two sheet metal bodies but is almost essentially continuous. This might be a good area where you can use a multi-body sheet metal part. But once again, if it's fairly complex, you're generally better off creating multiple sheet metal parts for each of your components. We're going to work with this circuit board to create our enclosure. And initially I had an assembly with this Arduino PCB board, but I simply saved it as a part to make it simpler and quicker to rebuild, as we don't really need all those separate parts for all of these individual entities on the PCB board. So first thing I want to do is make an assembly from this part. And especially when creating enclosures, I don't want to just drop this PCB board off in a space and then move it around or mate it later, I want to click on the Feature Manager design tree and click on the origin. So this comes in with the planes lined up. You'll notice if I go into this part that the planes are roughly centered around this part. And once I drop it into the new assembly, the planes are all lined up. Before we go any further, I would save out the assembly. If you look at this assembly, I had built this part 8, which is the enclosure, as a part within the assembly, and then I saved the assembly as a different name later. And what happens there is that you actually break the reference, or you lose the reference, and you have to update this to get it back, or you have to change the name of your assembly, which generally isn't much fun to do. So as soon as you have that PCB board in there, I'd save this out. I'm going to call this Arduino assembly. And then I can go ahead and begin to build. And I'm going to go ahead and insert in a component. And within this Arduino folder, I have something called a fake PEM, which is meant to be a sheet metal PEM, or represent the spacing that we would have for a PEM. And I'll go ahead and mate in this PEM. And then I'm just going to go ahead and use the copy with mates on this item. And add this into each of these edges. And if you're not quite sure what I just did there, there is a video in the assembly section on using the copy with mates tool. Once I have this in place, I'm going to create a new part. And this is going to ask me to drop in the part on a plane, or I can simply drop it into space. And this is typically the preferred method, as this will line up the planes with the assembly and also with the initial PCB board. From here I'm going to edit the part, and first I'm going to go ahead and rename this part. I'll call it Arduino Enclosure. And I like to save these parts out externally. It's not absolutely necessary, but generally nice to save this out in that same path. One of the things to watch out for when working in context is creating too many references to different parts, and as a result ending up with a circular reference or a very long rebuild time. So as much as I can, I'm going to try to only refer to the PCB board. In this case, it should be pretty straightforward. Rather than creating my first sketch on this washer and then going off of the PCB board, we'll simply create the plane off of this back face. So the first thing I'll do is create my first sketch plane. And this is going to have an offset of 3 millimeters. And before I move on, this is going to be in millimeters. So we're going to go ahead and change the units over to the metric system. Now that I have this plane, I'm going to create a sketch on the plane and just arbitrarily draw in a center rectangle. I'm going to go ahead and make this line collinear to the power plug, and then I'm going to give this dimensions off the side. I'm going to make this 1 millimeter. I'm going to make the back 2 millimeters. And for this side, I'm just going to make this equal to the dimension on the other side. And this is going to function as a base sketch so that when we update these things together, or update the enclosure or PCB board, everything should update together. So the next thing I'm going to do is create a sketch on the front plane. And this will represent our first base flange. Draw one across and draw one up. And I'll go ahead and make these two lines equal. Give this a dimension of 17 millimeters. And then I want to make these points coincident, or rather pierce, these lines. So once again, add that pierce, and I'll make this vertical. Then I'm going to go ahead and use the base flange tab. And I'll choose that point and choose a direction 2 and choose this point. And for some reason my preview isn't updating, but it will use this vertex as the endpoint once I click OK. Before I do that, I just want to verify the thickness and the radius, and this is going to be 0.6 millimeters and 0.8 millimeters. And I just want to reverse the direction. And I can see if I reverse the direction, this interferes with this PEM. But I do want this to be coincident to that face. So I'm just going to make a quick update to my base sketch. And this is why it's nice to work off of a base. When we update one dimension here, pretty much everything is going to update. So I'll go ahead and just offset this by 0.6 millimeters. And now we have this flush with that power plug. Next, I'm going to use the break corner tool. And I'll choose these two faces. And use a radius of 4 millimeters. Typically, I like to work with parts that look as though they're going into production, or have a production look, or are simply just attractive to look at. So I typically add in an appearance pretty early on in the process, as it's sometimes a little boring to look at a gray part. So now that I have my first sheet metal body, I want the next body to be on the inside of these faces. And I can see if I keep this as it is, I'm going to have a little bit of interference with this PEM. So I'm once again going to go back into the base sketch and update this to 2 millimeters. And it should update on both sides. Then I'm going to go ahead and create a sketch on this face and use the convert entities. And then I'm just going to delete out that extra line at the bottom. And then drag these points out and make them coincident to this sketch. From there, we'll create another base flange. And I'm going to go ahead and reverse that direction. And for the direction 1, we're going to do an up to surface. One of the benefits of working in this manner, or using these in-context relations and things like up to surface, is that when you do go ahead and change something later, for example this spacing maybe, or this width, everything's going to update. So the next thing I'll do is create another corner break or break corner feature, and we'll create these on these two side faces and give this a radius of 0.8 millimeters, same as the bend radius. Next, I'm going to go ahead and hide out that initial body, and I'm going to create an edge flange off of this edge. And I want the flange position to be on the inside so it's flush with the rest of the part. And we're going to use a rectangular relief in this case. And I'm going to go ahead and edit the flange profile. Now I want to go ahead and give this dimensions. I'm going to make this 3 millimeters. Go ahead and make this width 3.5 millimeters. And I'll make that hole 2 millimeters. Now I want to go ahead and mirror over this feature to the other side. And when you're working with sheet metal enclosures, or pretty much any parts in SolidWorks, it's good to think in terms of how you can reuse geometry or how you can quickly recreate it using either mirror or a linear pattern, as it'll save you quite a bit of time. And I'm just going to go ahead and create a midplane. Using these two planes so that I have a mirror plane. And once again, I'm going to use the mirror tool and mirror over both of these features. Next, I'm going to go ahead and show that first base flange again. And now I'm going to create cutouts for these two plugs. So once again, I'll go ahead and create a sketch. And once I create the sketch on that plane, I can go ahead and hide out that body so I can see both of these and select their edges. And I'm just going to go ahead and use the convert entities and choose out these edges. And I could create these cutouts this way, or I could create a slight offset as well if I want. And I'll go ahead and do the same on the other side. And then we can use this to create a cut into this body. And I'm just going to use the link to thickness. And there we have our cutouts. Next, I want to create holes for these tabs. And so I'm going to go ahead and use the hole wizard. And I'm going to create 2mm through holes. And we'll go ahead and create 2 on this face. And we'll go ahead and modify the position after we create the feature. I'm going to use an up to next. And then we're going to go ahead and modify that sketch. First, I'm going to go ahead and once again hide out this body. And then I'm going to edit this feature. And we'll simply just go ahead and drag this to the center of each of these circles. Lastly, for this feature, we're going to go ahead and mirror it over using that new plane that we created. And if we rebuild, that body at the front reappears. I also have mounting holes from the PCB board that I need to create. So I can also create a sketch on this face. And be careful when you're working with in-context references that sometimes you accidentally create a sketch when not working in the part. And this is going to be created outside of the part, so it won't be as useful to us. But I'll go back into the edit part mode, create a sketch, and hide out this feature once again. And here I'm just going to go ahead and convert over all 4 of these edges. Then we can create an extruded cut and use the link to thickness. And typically the body won't disappear. For some reason this is requiring me to rebuild to get the body back. So lastly, I have some screws I want to add and some holes I want to create for ventilation in this part. So the first thing I'll do is create a sketch on the side face using the corner rectangle tool. And I'll go ahead and give this some dimensions. And I'll go ahead and create a cut from this. And then we can create a linear pattern. And we can do the same on the other side by using the mirror tool. And I'll talk about this again in a later video. But for a linear pattern, the number of instances is something that you can change based on an equation, and so is the dimensioning here. And so as we update the length of the part, we can have these vents update if we want as well. But I'll cover that in a later video. A fairly convenient tool to use if you're trying to create a lot of cutouts in a pattern is the fill pattern tool. I'm going to go ahead and keep the default layout as well as the 60-degree stagger angle. I'll choose the create seed cut with a circle and just make these 2 millimeters. Keep in mind with this tool that the fill pattern will cut through the entire part in a single direction. So we actually have to select out the bottom face in order to only cut out from the top of the part. Lastly, I have some screws that I want to add to the part, or rather the assembly. And I'll go ahead and mate this in to one of the holes, and then I'm going to use the copy with mates once again. And add these into each hole. And there we have our completed enclosure.